x, y. Natural numbers are the numbers of 1, 2, 3, 4, not including 0. In other words, the positive integers. Now we're looking for all natural number solutions in ordered pairs to this result here. The square root of x plus the square root of y is equal to the square root of 175. Now, a common approach is to just square both sides, but you're better off isolating one of the variables. It could be either x or y, and that'll play into the solution here in a little while. But so this statement right here is absolutely equivalent to this statement. It turns out it's a little bit easier to square this than it is to square this. So that's what we do. And right here, if you just take a look at this statement right here, this is just the same thing as the usual difference of two squares result. This would be a squared minus 2ab. Okay, and a lot of you probably don't need to see this, but I'm writing it down. Plus b squared. So that's the form that we're getting when we square the right-hand side here. And when you square the left-hand side, when you square the square root of x, you just get x, right? So that's how we get x isolated in terms of y. Now, everything inside here is an integer. X is a natural number, y is a natural number, everything else is a natural number. And so what we can do right here is rewrite this radical piece right here, this radicand, in its prime factorization, which is not hard to, it's real quick to see that 25 is a divisor of 775, 31 is a prime factor here. And so because everything is a natural number, this entire piece has to be a natural number. It's just closure properties. If everything's an integer around you, you have to be an integer also. And so this result turns out to be quite useful because when you square both sides, you get that m squared, and m is just an arbitrary natural number. Okay, that's because the square root of 31y is a natural number. We can set it equal to this natural number. Okay, now we get 31y is equal to m squared, but that implies that m has to be a multiple of 31. Sorry, y'all, I had to use a subscript here, m sub 1. Anyway, the idea is that if 31 is a divisor of something squared, it has to be the divisor of the something, okay? So we get this truth right here, okay? Now, in a similar fashion, we could have isolated y and we would have gotten x is equal to some other multiple of 31. So these two statements are very important right here. These two statements are very important. We get x and m are multiples of 31 m squared, okay? So I'm sorry, they're multiples of 31. I didn't quite say that correctly. Okay, and so what we do is we conclude from when you substitute back into this expression. If you substitute these results, okay, if you substitute these results back into this expression right here, you're going to get this statement right here. Okay, now I did leave out just a little bit of the steps, but I think we're good here. And again, y'all, these are the two statements. I was pointing at the wrong spot. These are the two statements that are important that we substitute back into the original equation. Okay, I'm just talking too much here. You can see what's happening here. Now, the nice thing happens right here. We get this very pleasant result right here. The sum, these two guys sum to 5, and they're natural numbers, right? They sum to 5. And there's only two possibilities, namely 1 and 4 and 2 and 3. And when you do the arithmetic, that is when you substitute, when you use these two guys right here, and you go through these possibilities, m2 equals 1, m1 equals 4, and m2 equals 2, m1 equals 3. Those are the only two sums that give you 5. You get these ordered pairs right here, and I'll write it out here. This is, and I'll just come and write the solutions up here, folks. You have 31, 496. Probably better I didn't talk. Enough is written down to where probably I could just, you guys just look at it, without listening to me talk. But you get 31, 496 is an ordered pair solution. Now notice we can reverse this because these are definitely symmetric. We could have isolated x or y, and also you would get 496 496, comma 31, right? That's one pair of solutions. And also down here, when you go through the case, m sub 2 is equal to 2 and m sub 1 equals to 3, we get the symmetrical solutions, I guess you could call it 124, 279. And again, it's very natural to believe that you can just reverse these, since there's nothing special about X and Y. That's the same kind of processing, if you will, whichever one of those you choose. Okay, so 279, comma 124. Y'all, I got to get a little faster writing with this Zoom pencil here. Yeah, so there are 4 solutions, and really, it's, to say there's 4 is just because of the way the problem's worded, but anyway, these are the solutions. 31,496. What did I do there? Did I write that? Yeah, I got these right. 31.